Hello. Okay, it's time for our next presentation, Reactive Java EE. And afterwards, when it's time for questions, we have a mic over here, because this presentation is filmed, so we need to get the questions on mic. Please welcome Ola Petersson.
Thank you. Now we had a bit of technical difficulties, so I had to switch to my backup laptop. But hopefully this won't be as much an adventure for me as it will be for you. We're going to talk about Reactive Java EE. We're going to have a bit of look about reactive systems, what they are, and how we actually can implement it in the ecosystem of Java EE. But before we start, I just want to mention a few words about me. My name is Ola Petersson. I'm from Sweden, as you might hear. Live and work in Gothenburg with full-stack web applications. I every now and then go on conferences as well. And as of last week, I'm a Java 1 rockstar, which I'm very proud of. Thanks. If you want to reach me, you can reach me at go2ola at Twitter. It used to be a different handle, but people never found me, and I hope that programmers can relate to this Twitter handle instead. Send me a mail if you do that kind of thing instead at ola.petersson@squeed.com. I work at a company called Squeed. We are software consultants, and we are really passionate about competence, gaining competence, sharing competence within the community. We are the host behind something called Java Forum Göteborg, and we are always looking for speakers. So if you want to share your knowledge with us and happen to trespass to Gothenburg, come and speak to me after this talk or visit our booth here at JFocus. Now, I always get inspired by music, and this time it was by Queen and their #1 hit song, The Show Must Go Wrong. So we're gonna do some live coding and some live demo here today with some graphical artifacts. This is an ordinary web page. You have seen these before. When we reload it, we'll go out on the web and we'll get tweets under the hashtag JFocus, if the internet god is with us. So as you see, this isn't really reactive or responsive. Right now it's not working at all. We're gonna have a look and see what we can do to make this a bit more reactive. So let's have a look at a very common pattern that I see in code every day. And that is that we'll get in a request to our system, and the first thing that we do is to just dispatch further down into our business code. We call a business server to perform something heavy, do some lifting for us. Eventually, that business service returns to us, and we return out to the rest of the world. Now, we do this in the HTTP case. So we get a request into a REST endpoint, and we hog on to an HTTP thread. Now, the first thing we usually do is to call a business service. But during that whole duration, we are blocking this thread. We are telling it that this is now ours, and nobody else should be able to use it. And eventually, we let go of it when we return. But why do we do it like this? Why don't we do it a bit more like this? Where we get the request and we dispatch further down into our business code, but then we let go of the HTTP thread, allowing it to serve other users who are coming into our system. And this is a bit of asynchronous code or non-blocking code, where we are freeing up resources. And this is one of the core concepts in reactive programming. Now, if we take reactive programming and look at another abstraction level, we start to talk about reactive systems. And reactive systems are, it used to be quite buzzwordy, but today we have something that's called the Reactive Manifesto. How many here have heard about or read the Reactive Manifesto? About 25%, maybe a third. So the Reactive Manifesto was taken forward with the help of the Swedish Java champion Jonas Bonnier, among others. And what they come up with was that the reactive system should fulfill these 4 traits. Now, the main point why we are looking into reactive programming is that we want to be responsive. We want the end users to have a feel that our application is fast, that almost everything is happening in real time. Reactive system should also be resilient. Now, I know that we call them exceptions in Java, but if you have had a look at my code, you wouldn't call them exceptions. They do happen, and they will happen. So what we can do is that we can strategize of how we do when they happen and still support the responsiveness in our system. Reactive system should also be elastic, and an elastic system can grow when we are under a huge load. But compared to scalability, an elastic system also shrinks when we aren't under that huge load. And all of this should be built on an asynchronous message-driven foundation, allowing us for high throughput to send messages, both as errors and to support the responsiveness in our system. Now, that was a lot, and I recognize that this is early on in the conference, so if you kind of stopped listening, this is the too long didn't read of this talk. And that is that we shouldn't block our resources. We should aim to be responsive. But why? I mean, why should we care about reactive systems? Well, first of all, hardware has gone through quite amazing evolution in the last 5 or 10 years. Even in my phone today, I have several cores supporting a lot of threads and a lot of parallel computing. So we should utilize the resources that we have there. Also the availability. Even my grandfather, who's 87 years old, can visit my site through cell phone or smartphone when he goes to the toilet. So users can, we have a lot more users on the internet accessing our sites. And of course, the most important thing is that the end users has grown adapt to things like Twitter, like Netflix, like Facebook, where we almost get the feeling that we are there in real time. It's displayed when we get a notification. So if they've grown adapt to it, we should, of course, satisfy them, because in the end, they are the ones who are bringing in the money for us. So that's the what and the why, and we are going to have a look at the how here today. And this will be the dish that I serve you. This is the APIs in the Java EE, which have a bit of reactive traits within them. And we're going to have a look at the WebSocket. We're going to have a look at EGB with message-driven and asynchronous message beans. We're going to have a look at CDI with events and observes, JAX-RS with async on server, a bit of JMS, and the concurrency utils. So, the reactive manifesto says responsive. Then I say WebSocket. And what a WebSocket is an ordinary HTTP call that we send down to our backend, which also asks for an upgrade. And after a bit of handshake, we end up with a WebSocket and full duplex communication between our client and our backend. Now, what we will build with the Java EE APIs here is the backend WebSocket of a server. And how we do that is by starting off with an ordinary repodio. This is called Hello WebSocket. We will annotate this with the server endpoint. And this exposes a path. This is like the REST path that we're used to. So this is where people will find us on our server. We'll call that Hello WebSocket. Now, that's good. People can find us, but we also want them to be able to connect to us, so we can have this full duplex communication channel. And we do this with the onOpen annotation. Now, when we annotate a method with the onOpen, the API is expecting us to take care of a JAVAX WebSocket session. And the JAVAX WebSocket session is the client that connected to us. Now, from that session, we can take an async remote, and that's the remote back to the client, and send them the text that you are now connected. And that's cool. They can find us, they can connect to us, and we can tell them that they did connect to us. But of course, we also want to deal a bit with communication. And we do that by annotating a method with the onMessage annotation. So we'll have an onMessage. This also takes a session, the session that sent us a message, as well as the message. So again, let's take the async remote back to the client and send them the message Pong. Now, before I got here, on the JavaScript part of it. In an ordinary browser with vanilla JavaScript, what I did was that I created a new WebSocket. So we will have a handle to a WebSocket variable. I connected it to my endpoint. And in the same way, we can bind these specified methods, like on message, on the client. And what I'll do is that I will log it out into the console. We can also, of course, send messages back down to our client or to our server, backend server. So if we go back to our site and we reload it, we get a lot of errors. But we also see here that we are now connected. And this is what the backend server told us. Now, what we can do is to send a ping and receive a pong. Thank you all for showing up. Take care. Okay, this is a pretty lousy functionality. We don't even have a REST endpoint anymore. We have a ping and a pong service. But what we can do to make this a bit more interesting is that we can add a bit of state to our WebSocket. So by adding a set to our endpoint or to our WebSocket, a set of sessions, we will call this peers. New hash set. Now, whenever somebody is connecting to us, we can take the peers and add the connected session to our peers. Now, whenever one of the peers is sending a message to us, what we'll do is that we'll loop through each of the peers, and we'll take that peers remote and send them the text that we got. So recap. We added some state to our WebSocket. We have a set of sessions. Whenever somebody is connecting to us, we store those sessions. And whenever we receive a message, we push it out to all of our clients. Now, when we go back, we will open two different terminals. The one on the right here is an incognito tab, so these don't share any kind of data with each other. And hopefully, when I now send a message from the left browser, you'll see that it's displayed in the right. So basically what we just built is a chat application in about 5 minutes. Now, I think you will have a really hard problem selling this chat application. You are free to try if you want to. But we have the basic functionality of being able to push out whatever message we get out to the rest of the clients. So whenever we get data in our backend server, we'll use the duplex communication channel to push it out to the clients. WebSockets are supported in all the major browsers. I think Opera Mini doesn't support it. So if you need to support Opera Mini, you're running out of luck. But otherwise, it's supported everywhere. And if you're writing microservices systems, you can, of course, also write a Java client. Okay, so something like the implementation I just showed you is something we will utilize throughout the rest of the talk. Now, the Reactive Manifesto says that we should be message-driven. Then I say a message-driven bean. Message-driven bean is an annotation that we put on our enterprise Java beans. And with the annotation, we also add something that we want to listen in on, like a JMS queue, for example. Now, whenever something is put on that queue, we will trigger the MDB to be able to react in our system and push it out to our clients. The MDB is usually used with JMS, and this is how I've always used it. But it's actually using the connectors in Java EE, so you can listen in on Telnet if you want to. Now, what I did before I got here was that I wrote a REST endpoint, which will put JMS messages on a queue. what we will do is to write the MDB which listens in on this queue. Now, we have a WebSocket, so of course we can also inject that WebSocket and push out this message immediately out to our clients. So let's start off with another POJO. This is called message-driven bean, and what we'll need to do is to add the annotation at message-driven to our bean. We'll also add a mapped name. This is to the example queue that I prepared before I got here. Now, I know that we are listening in on JMS, so we can implement the message listener interface of JMS. Now, what this will do for us is that whenever we are getting triggered, whenever something is put on the example queue, we will trigger this on message method. Now, first I want to get text messages, so let's just cast the message to a text message. But what we now can do, as I said, is to inject a WebSocket. And with the WebSocket, let's send the text that we got from Mr. Bean. Now, what you'll see is that when we get the text from our JMS message, something can go wrong. We can catch a JMS exception. Now, since we have the WebSocket and we have the functionality to be able to actually inform our clients on what is happening, instead of just letting them wait, we can send them something informative, like the big no. But we'll respond to them immediately to let them be aware of what is happening within our system. Now, I'll redeploy this, and we'll go back to our site. I'll do one more thing before we have a look at it, and that is that I will only enable WebSocket communication within our application. And we will have... The internet is not with me. I should have sacrificed one more goat to the demo gods. Okay, so since I didn't sacrifice enough goats to the demo gods, we are gonna have a look at the video on what we did instead. So in this video, I will use the nifty little Swedish invention curl, and I will put a message on a JMS queue using this curl command. Now, as soon as that is sent on the queue, we'll push it out to our clients. I think this is really, really great with the MDBs, because queues are what we usually use to integrate with external systems. So even if we are integrating with queues towards something really legacy, we can be very reactive within our own application. Now, MDBs has a lot of traits which are really good as well, and that is that they are fired asynchronously by default. They are, we are running several of them in parallel, allowing us to get a lot of throughput. And by talking with MDBs and with queues, we of course also get a lot of separation and isolation. The producer is there, and it puts some messages on the queue, but we don't need to care about how it does it. So we are very loosely coupled with WebSocket. And this is good if we are integrating with external systems. But also, maybe we want to get these kind of benefits internally within our own system as well. And what I'll have for you in that case is the event and observes. And the event and observes is part of CDI. And what it basically is a pub sub pattern for typed objects. And what I mean with that is that we'll fire an event within our system, and we are telling it that we are firing an event of the type myClass. Now, we can add one or several observers reacting as soon as we are firing events within CDI. So we get the same benefits as the message-drivenness of an MDB. What I did before I got here was that I added a little poller on Twitter and whenever we get a tweet, we will fire that out to allow the rest of the system to know that we got a tweet. And if we have a look at the code, what we will do is to fire an event in this method. We will call this method whenever we pulled a tweet. And the first thing we need to do is to inject an event, a JAVAX enterprise event of the type tweet. Now we'll call this tweet event. And whenever we get the tweet, and whenever we want to announce to the rest of the system that we got the tweet, we'll take the tweet event, and we will fire the object that we want to fire as an event. And this is quite neat. It's not much code to announce to the rest of the systems that, hey, maybe you guys are interested in this. But of course, we also need to have something actually listening in on it. What we will do then is that we'll implement an onTweet method in another bean. It could be anywhere in our system. And we'll add the @observes on a parameter of the type tweet. Now, whenever something is fired of the type tweet, we will trigger this method. And by now, you know the deal. We will inject a WebSocket, and we will push out the tweet to our clients. Now, I learned from my mistakes, and this will probably not work on the internet, so we will jump to one of the cheating videos instead. So this test was for Java 1, but what I will do is that I will send a tweet, and when I put it on there, we'll trigger the event and fire it out into the rest of the system, and we will immediately push it out to our clients. And this is, as I said, we will have the same benefits of loosely coupling as we have with the MDB, and we can allow several other observers more than just our client pusher to observe on these events. But when you start to read in on the events and CDIs, you'll see that they are actually fired synchronously. And that's not good when we want to build a reactive system. Now, we want to fire it to allow others to observe it and react on it, but we want to continue with our own stuff without having to wait on them. And then we need to introduce one more thing into our little observer, and that is the @asynchronous annotation. This is part of AGB. What you will do is that you will put the @asynchronous on either class level or on method level. When you put it on class level, all of the methods in that class will be run asynchronously, and when you put it on method level, just that method will run asynchronously. So, of course, we can do this by adding the @asynchronous on our observer, and also make it an EGB by adding the stateless annotation. Now, what you're obliged to when you annotate something with asynchronous is that you'll either return void or a future, a Java SE future. But doing this, we will get the same benefits as we did with MDBs internally in our systems. Now, I'm going to introduce the last thing here today, and that is where we started. When we get an HTTP request, we want to hand back that HTTP request or HTTP thread to the pool to allow it to serve others. And what we have in Java EE in that case is the async response. This will allow us to perform asynchronous backend, asynchronous REST in our backend. Now, if we look at a quite ordinary REST endpoint, you'll see that we'll come into the path sync with get, and we'll call the get foo to get the string foo, and then we will return. And this doesn't look that dangerous at all. It's a quite common REST path or REST endpoint. But I hired a summer intern to help me out with this presentation. And he added something that's called sleep thread down here. And sure enough, if we run this, we'll see that this method takes 500 milliseconds to finish. Now, if you don't believe me, he even left the author as the summary intern, and not Ola, if you still don't believe me. But what this will do is that we will block an HTTP thread for 500 milliseconds here. And maybe we want to hand it back instead. So let's see what we can do to improve this with an asynchronous behavior. Now, the first thing we want to do is to change the return type to void, because we want to give it back immediately. We don't want to wait for a value to come. We also need to add the @suspended annotation on an async response. And what this will do is that it will kind of inject the request context into this async response, allowing us to answer on that request from any thread that we would like to answer from. Now, this will make this method run asynchronously, but if we just do this and do the get foo within this method body here, we haven't gained that much. We will probably just use another thread from the HTTP thread pool. And what we can do with the concurrency utils is that we can resource inject and manage execute the service. And the manage execute the service is something like a handle to a thread pool, but we will get application managed threads. So by using the managed execute the service together with the completable future API, where we can supply something asynchronously, we can write the completable future supply async, meaning that we will go out into another thread. This expects a supplier. And if you're up to date with your Java 8 syntax, you'll realize that this parenthesis, it's like a method reference or basically an anonymous inner function. Now in this other thread, we can take the response and resume it with the get foo value. So this is the first parameter, the supplier, and then we can give it the managed execute the service, allowing us to specify which thread pool we want it to run in. Now this will give us the default execute the service, but we can of course add a map name here to add any thread pool that we want to. But this looks a bit unintuitive. I mean, why do we do this and what do we gain from it? Well, this becomes quite evident when we are under pressure. And what I did to simulate that we were under pressure was that I used the Scala tool Gatling. And I absolutely recommend everyone here to try out Gatling on your existing systems today. And it's a load test tool, so you can fire off concurrent requests towards your REST endpoints. I did this with 100 requests, and to simulate that we were under really huge pressure, I minimized the HTTP thread pool to only 5 threads. Now, what I saw in the first implementation, where we are hogging the HTTP thread during the whole duration, was that the minimum value, it was 500 milliseconds. And that's what we expect. The first guy got served in 500 milliseconds. Now, the 100th guy, he wasn't that happy, because he had to wait for 10 seconds before he got his response. And if we look at it, the mean value was actually 5.2 seconds. So this isn't really that reactive. We aren't scaling that well. Now, for the second implementation, still using the 5 HTTP threads, we see that the minimum response time was 500 milliseconds, but the mean value for all 100 were 565 milliseconds, and with a standard deviation of 27 ms. So we are almost serving at the same pace when we are hit concurrently with 100, even though we are only using 5 HTTP threads. So this is really good because we are using our resources and letting them serve HTTP requests instead of just blocking. Now, there's no black magic here. We are still using threads. We are just using them from another thread pool. But we can put a lot of resources into that heavy lifting thread pool. So we allow the HTTP threads to only accept connections, and then we are letting go. instead of waiting on the heavy working tasks that we have in our system. Now, the Reactive Manifesto also says that we should be resilient. And I won't show you some of the patterns with resilience here today. But if you go to microservice talks, or if you have been going to microservice talks, you've heard about things such as circuit breakers and bulkheads. Now, they are of course good in a microservice system, but they are really just there because we are sending messages between our microservices asynchronously. And we can of course use these patterns internally within our own system as well. Now, if you want a reference implementation, I suggest that you check out Adam Behan's GitHub and blog, where he's actually made both a bulkhead implementation and a circuit breaker in plain Java EE. Now, the last trait that we have in the Reactive Manifesto is elasticity. And here we are kind of running short in the Java EE specification. There's nothing really in the Java EE specification which defines how we can scale and shrink our whole system. Now, things like the MDB, it has a bit of an elastic behavior, but on a wider system level, we are running short. And we might have to look into Kubernetes or other software to fix this issue for us. Now, this is the black slide. This is where I put my disclaimer to not do anything of this. And I don't really mean that, but asynchronous programming, having a lot of parallel running threads, is always harder to program and to debug than writing your ordinary synchronous code. So if you decide to go down this path, make sure that you are really getting the benefits from it. Now, I still think that you should use it, but think about it before you start to use it. When it comes to the future of Java EE, this is the technical focus, or a part of the technical focus that Oracle has said that they will put into Java EE 8 and Java EE 9. And that is a programming model which they will extend for reactive programming. They want to support things like resiliency and also eventual consistency, which can happen in asynchronous running systems. So the future will probably be even better. But all the things I showed you here today, you can go home and do after this talk. Now, that's actually everything I had for today. If you want to revisit these slides, you can check that out, widr.se/OLB. I will bring this slide up again later. You will find all the references there, like my GitHub, my speaker deck, the Reactive Manifesto, etc. But other than that, I just want to say thank you.